Hello everyone, this is Shakil, and today we are going to discuss a very important topic from A to physics, which is medical physics. And inside the medical physics, today we will be looking upon X-rays. So X-rays are really important in everyday's life. If you uh, go to a dentist, he is going to scan your teeth through X-ray to see the image of any cavity over there, or if someone is having a broken or a cracked bone, then the X-ray image is going to taken that will reveal all the details about the bone. So let's study that. We have to see how the X-rays are produced and what are their uses and how fine quality images are obtained and upon which factors they depend and how they attenuate. So first of all, we have to see that how X-rays are produced, and these are actually produced by bombardment of electrons on metal target. And then we have to see that different types of X-rays are being produced. And then we'll be looking upon X-rays in imaging internal body structures, including the understanding of term contrast in X-ray imaging. Then we have to look for the intensity related to X-ray as they travel through the matter. And then our next topic would be computed tomography, but we'll be looking upon that in the next video. So in this video, we are going to focus on these 3 points. So in medical diagnosis, it's really important that um, all the details are going to be looked upon. There are two methods. One is in invasive technique and second is non-invasive technique. So in invasive technique, they are just going to touch your body. Let's say if you are a fever, so the doctor can touch your body and he can feel that your body is hot, burning hot, and then he can suggest some medicine. In non-invasive technique, of course, the latest technology, the modern technology is going to be used. Let's say these two persons are taking are holding the X-rays in their hand, so they are looking upon some bone images that are taken through the X-ray, and they can study it in depth. Okay, so we have to see that what is the nature of X-ray and how we produce that. So we know that X-rays are the form of electromagnetic radiations. They belong to, of course, the shorter wavelength and higher frequency range. Of course, after that are only the gamma rays that are having the highest frequency. They have wavelengths in the range of 10 power minus 8 to 10 power minus 13 meter, and effectively the same as almost same as the gamma rays. The difference between them is the way they are being produced. So first of all, we have to see that how we use X-rays in medical imaging. These are high frequency radiation. They have strong ability of penetrating in matter. This is the unique thing that we focus upon. That's why we use them in medical imaging. About production, we have to look for the X-ray tube. So X-ray tube is actually a device that is going to produce X-rays, and these X-rays are instantly produced. So let's look upon the working principle. Before looking on the working principle, we have to model it. So um, first look at this thing. Let's say this is an X-ray tube, and from here this is the low voltage battery, and then this is the filament, and the low voltage battery is going to heat up the filament, and then the beam of electrons are going to be produced. Then of course the tube is filled with vacuum so that the electrons may not decelerate, and then this one is the metal target. So electrons hit the metal target, and when they hit the metal target, they decelerate and they emit all their energy. And when they emit all their energy, that energy is radiated in the form of infrared rays, in the form of light rays, in UV rays, and some are in X-rays. So if you want to produce X-rays from the decelerating electron, of course you have to accelerate them higher. So that's why we use this very high accelerating voltage in the range of 50 to 200 kilovolt, and this is between the metal target and the filament, so that when the electrons are produced from the filament, they accelerate at very high rate, very high speed towards the anode. And when they decelerate upon hitting the anode, they emit all their energy. So as they accelerate more, they have more kinetic energy. And when they decelerate, they emit their energy in the form of X-rays. And then it is the rotating anode, because a lot of heat energy is going to be produced. So there should be a system that should be extracting heat from that. Okay, coming back over here, if you look closely, this one is the metal target, and then behind it is a copper block, and inside the copper block, the cooling water tubes are there. Why? Because when the electrons are going to hit the metal target, then of course it is going to produce a lot of heat energy, and that heat energy would be quickly absorbed by the copper block, and then inside the copper block, the water tubes are there, so they will be taking the heat away from there. So on your left side is the low voltage battery connected to a filament, and when low voltage battery will be switched on, it will be producing a lot of electrons through thermionic emission, and then these electrons will be moving towards the metal target and again inside the vacuum. And when the electrons is going to hit the metal target, which is usually made up of tungsten, then those electrons are going to decelerate, and hence they will emit energy in the form of X-rays and many other rays as well. Okay, now about this tube, these series of crosses, you can see the series of crosses over there. These series of crosses are actually the lead insulation, so that the X-ray may not escape from any other part of the tube. So X-rays are only going to leave the tube from the window that I am shading with green. So this is the window, X-ray window, through which X-rays are going to be filtered out. And this X-ray and this X-ray window is actually made up of aluminum, because aluminum is going to allow only high energy X-ray to pass through them, and it blocks the soft X-rays. What are the hard and soft X-rays? We'll study later, but soft X-rays are the one which are having low energy, and hard X-rays are the one which are having high energy. So what's the working principle? When charged particles are rapidly accelerated or decelerated, then they emit radiations. Okay. So let's look upon the working. The low voltage battery is connected to the filament F. Electrons are produced by a process of thermionic emission in the filament. Number of electrons produced depends upon input voltage of the low voltage battery, and then high voltage external source is used to create a potential difference between electron 1 and the target metal. Electrons are accelerated in the vacuum towards the target, and upon hitting the target, solvent things happen. Okay, when the electrons hit the metal target, two things can happen. Number one, multiple accelerations, decelerations of electrons, leading to emission of energies in X-ray range. And number two, thermal energy is produced in metal as well, because not all the electrons are decelerated at once. They can be decelerated in multiple steps when they hit the metal. So upon every impact with the metal atom, they lose some of their energy. So if electron loses all their energy upon single impact, that will be the X-ray. And if electron lose their energy in steps after collision with the atoms, they lose their energy in fractions. So that would be less than X-rays. That would be an infrared or light rays. So X-rays radiation produced will have a range of frequency or wavelength of energies. This is due to the fact that accelerating electrons are coming to rest after a number of collisions with target metal atoms. So it means that all the X-rays that are being produced will have different wavelengths. So suppose if all the electrons are coming to rest at single collision and maximum energy radiation, you got maximum energy. And when you got maximum energy, then the frequency is higher. So higher frequency X-rays are emitted, and that are very useful for us. These are known as high energy X-rays. Okay. And then if electrons are coming to rest after multiple collision, range of energies are going to be emitted. Okay, what is meant by intensity of X-ray? Well, intensity of any wave is energy transferred per unit area per unit time, or it is power transferred per unit area. So the intensity of X-ray means how many X-rays are going to be produced. So the intensity of X-rays are depending on number of electrons hitting the target. Number of electrons. So if more electrons are hitting the target, it means more X-rays will be producing over there. And number of electrons depends upon tube current or potential difference across the filament, right? So it means that the intensity of the X-rays are controlled by this thing, So this is, let's say, EMF of low voltage battery. So this can control the number of electrons, because if you increase this voltage, then more electrons will be produced. And when more electrons will be produced, then more X-rays will be produced from there. Okay, so now let's move on to next thing, which is hardness of the X-rays. Hardness means how much energy they got. So there are two types of X-rays, soft X-rays and hard. Soft X-rays are low frequency X-rays. They have less energy, they have less penetration in matter, and they're not suitable for imaging. Because once they got into your body, they will be trapped over there because they have less energy. They cannot go out of your body, and they can cause harm to your cells. Okay, the hard X-rays are the high frequency ones. They have greater energy, they have greater penetration, and they are suitable for imaging because once they have high energy, they will hit your body and instantly they will leave your body out, right? And some of them will be absorbed by the hard tissues and the remaining would be gone through the soft tissue. So that's how we can take the image. Okay, so let's look upon their energy relation, how X-rays got their energies. So you know that kinetic energy of electron matters because when it will decelerate, it will emit the same amount of energy in X-rays. So we know that the electrons are being accelerated by the outer potential difference. So the potential difference is work done per unit charge, work done is charge, potential difference into charge. And then we know that, okay, this work done is actually the kinetic energy. So the kinetic energy of the electron is equivalent to product of charge on electron and external potential difference, which is like the high voltage. So this is the input energy. So this is the input energy. Kinetic energy of electron is EV. Now energy emitted by as X-rays, we know that X-rays are having energy in the form of photons, and which is E equals HF, X-ray photon energy. So we say, okay, the kinetic energy of incident electron is having energy of EV, and then this EV will be equal to HF, like input energy is equal to output energy, or you can say EV is HC over lambda. So soft X-rays are produced due to multiple deceleration of electrons with the target metal before coming to rest, and hard X-rays are produced when electrons come to rest upon first impact with the metal. So larger single deceleration resulted in hard X-rays, more energy. Well, let's look upon the intensity spectrum diagram. Let's plot all of it through all of the emitted X-rays with range of energy on this spectrum. So this is intensity wavelength spectrum. So first of all, it started off with X-intercept. So the X-intercept. So X-intercept means the least wavelength frequency. When lambda is least, then frequency is highest. So it means that electrons are going to be stopped at single collision. So these are the high X-ray energies. Then the number two part is the continuous part, this continuous part of the spectrum. This shows that electrons are experiencing multiple deceleration and they are stopping. They're coming to complete stop after several impacts with the atoms of the target metal, and they emit X-rays in range of energies. You can see the range over there. Number three are the spikes. These spikes are the feature of the characteristic spectrum of the metal. Like when electrons are going to hit the metal, they're going to accelerate the metal electrons, and when electrons will go to higher energy level, they will be in excited state, and when they come down, they will emit energy, they will emit the photons, and the spikes represent that thing. Okay, so let's have a graph explanation. I already told you, but let's just go through it. The cutoff wavelength or the minimum wavelength, we talked about it at point 1. Okay, so this is the minimum wavelength at which frequency is maximum. So the minimum wavelength or maximum frequency is of emitted X-rays caused by the single impact deceleration, like the electron is stopped at single collision with the metal target. Number two is the continuous part of spectrum, electrons being stopped as a result of multiple decelerations, thus emitting radiation in range of frequencies and wavelengths. So number three are the sharp peaks. This is due to the characteristic line spectrum of metal. Incoming electrons collide with electrons of target metal, provides energy to electrons for moving them to higher energy levels. When these metal electrons goes back to lower energy level, they emit radiation, hence intensity signal increases. Well, let's look upon the penetration of X-rays through matter. We know that X-ray can pass through matter, so X-rays can easily pass through matter, but its intensity certainly decreases. So what is attenuation? Attenuation is loss in intensity of X-rays due to traveling through matter. Like when the X-ray is traveling through any matter, it can be human flash, it can be bone, it can be any other thing, then of course its intensity decreases. Let's look through an example. This is I naught, it's the coincident X-ray intensity, and this is the organ of width X. And when this X-ray of intensity I naught goes through this organ, and when it leaves it, its intensity decreases to I. So the transmitted X-ray intensity, we know that the intensity is following inverse square law as well, but the equation can be exponential and like this: I equal I naught exponential minus mu x, or I equal I naught e power minus mu x. Same thing. What is I? I is the intensity transmitted through the organ. I naught is the original intensity. Mu is the linear absorption coefficient. It is related to the organ. It's a feature of the organ. And X is the width. And it's the width or the distance to which X-ray is moving. And its unit is per meter. Okay. Mu is actually the linear absorption coefficient, which depends upon density of the matter. Greater the density, greater would be mu, and mu have fixed values for all the matter. So let's look upon here. This is the intensity along y-axis and distance along x-axis. So if the X-ray is passing through air, let's say, so its intensity is not greatly reduced because it has to cover shorter distance and air density is very low. But if it is going through flash, its density decreases exponentially, and if it is going through bone, then there is a greater decrease in the intensity. And let's say after covering some distance in the bone, that intensity decreases to 0. That shows that different medium have different linear absorption coefficient. Bone is having the higher value of mu than flash, and flash is having the higher value of mu than air. So what is half value thickness, like the half-life? It's the thickness of the substance that decreases intensity of X-ray radiation to half of original value. That's quite simple. Let's say before entering into the organ, let's say if this is the organ, and before entering into the organ, the X-ray intensity was I naught. And as it starts traveling through the organ, till this point, its intensity decreases to half of original. So we say that, okay, this width X is the half value thickness. So this is the distance after which the intensity of X-ray decreases to half of the original, same as half-life. Okay, how the image is being formed? Well, or let's say these are the X-ray source, and this is the metal grid. This is used so that the X-ray, the parallel beam of X-ray can be used. And then the organ and the investigation is there. This is the hard part. So you can see that through soft tissues, the X-rays are passing through. And this is the X-ray photographic film. And then there is the lead absorber behind it, so that when the X-ray passes through the film, they will not be reflected back. So the image is transformed over there. So when you will develop that image, then it will be in the form of this. The flash part, the brighter area would be the harder tissue because X-rays are not passing through, and the darker area represent the softer tissue because X-ray pass through the softer tissue and they ionize the solution. So that comes in the form of dark shadow. Okay, soft tissues attenuate X-rays in very small amount, and as compared to attenuation by the thicker tissues or the bones, that's the key to take the image. X-rays reaching the film will ionize the solution in different amounts and creating darker, less darker, and brighter areas. And if we look upon the image quality, so two things are very important. One is the sharpness of image, how sharp the image is, and number two, contrast of the image. So let's look upon the sharpness of the image. This is the property of image by which boundaries of images can be clearly observed, like the sharp edges, right? And on which factors it depends? Well, number one, it depends upon decreasing the target area in the tube. Decreasing the target area means this target area, like this is your target area. So if you decrease this target area, you can get a relatively sharper image. Okay, where were we? Okay, we were here. And then the next thing is using aperture in front of the window of the X-ray tube. So you can use aperture like the one is using camera. So you can limit the amount of X-rays. You can make a fine beam by using a sharp beam of X-ray by using aperture in front of the window, and then avoiding scattering of the X-rays, of course. Okay, contrast. Contrast, means the difference in degrees of darkening and brightening of the image is known as contrast, and its factors are the exposure time. You have to expose the body for a longer time in X-ray, because so that the darker area become more darker and brighter become more brighter, and then scattering of the X-rays, you have to avoid that as well. Okay, so yeah, that was the last thing for today. So thank you, students. I am going to share some of the questions over here. Our next topic will be CT scan. I will be uploading that video soon. Thank you so much, students. Take care.